So taking the same question as we were discussing in the last video, for this particular graph we were trying to find out all pair shortest path. First of all, we have designed our adjacency matrix. So there are 5 vertices, and so there should be 5 rows and 5 columns. And for every connected edges, if there is a path, you have mentioned their corresponding weights. If there is no direct path, then you are simply writing infinity to those locations. Just like 1 to 4, there is no direct path, so we have written infinity. And as there are no self loops, so we have written zeros in every diagonal element. So this way you can prepare your D0 matrix. Now from this G0 matrix, we will try to find out our D1 matrix. So whenever you are trying to find out your D1 matrix, there few things are you need to careful. What is the first thing? First thing is that you need to take its first column and first row as same as D0 matrix. So whenever we are generating any DK matrix, we are going to take DK minus 1, its corresponding column and row value. So let's say we are going to take D1 matrix. So that is my DK, 1 is K, and so we will take from D0 matrix, K minus 1 matrix, its first row and first column as it is. So in D1 matrix, this value will be same. So this value we will take from D0 matrix, and their diagonal elements as they are 0, so we will specify as 0. Apart from this and this, you need to generate other values in D1 matrix based on the formula that we have suggested, like this. Fine. So in order to calculate Dij for kth matrix, you need to calculate a minimum of based on this. I will tell you just now. So let's see how basically we are generating D1 matrix. So as I have suggested in this video itself, that in D1 matrix your first row and first column is same as your D0 matrix, fine, and its diagonal elements are same. So now you can see how basically we can generate different values. So these all values will be generated based on this formula. So let's say Dij indicates, right now we are calculating the value of, let's say 2, 3, D of 2, 3. This value, let's say we are calculating. If you are calculating this value, let's say how you can calculate what is the latest value in D1 matrix. Basically you will follow the minimum of Dij from 0th matrix, means same 2, 3 in 0th matrix, and out of these two minimums, which one is minimum. And second thing you need to find out, D0 I of 1 plus 1 to j. So D0 matrix we will see. In order to calculate D1 matrix Ij value, first thing you should try to understand, in order to generate any matrix value here, let's say D of 3, 2 in D1 matrix, we need to generate value from its D0 matrix, fine. And what value you are basically going to take it? Same, first thing, whether it is minimum, already D0 value is minimum or not. And second thing, if it is not minimum, through 1, what is its path? So through 1, the path is known as I to k plus k to j. And what is k right now? Right now k is 1, because we are checking the path through the vertex 1. So here we will take, let's say for a particular example, so I have written here D23 you want to calculate. So how you will write D23 for this D1 matrix? You will calculate minimum of D0 matrix, which is showing 2, 3. So you go to D0 matrix, check the value of 2, 3, let's say 2, 3 value is infinity. So you will write it here infinity. And second thing, you need to calculate D of 2 to 1 through 1 plus 1 to 3 plus 1 to 3. So D of 2 to 1 is nothing. D of 2 to 1 is infinity, plus D of 1 to 3 is nothing. It's basically 8. Infinity plus 8 is nothing. It's basically infinity. So which one is minimum? Here both are infinity, so infinity. So you can see here we have written infinity. Take another example. Let's say we are calculating D of 2, 4. Same rule we will apply everywhere. The rule we have shown here. If we are checking the path through 1, k will be 1. Whatever value I and j row and column you are calculating, first of all you go to I and j column of its lower matrix D0 k minus 1 matrix and then find out through 1. So D of I to 1 plus D of 1 to j, and where you will add this two value from your k minus 1 matrix. So same way we have done here. Let's say we want to find out D of 2 comma 4. How we got this value? You can check it here. So we will go to D2 comma 4 for one matrix. We will first go to D2 comma 4 of D0 matrix. So D0 matrix, you go and find what is the D2 comma 4 is. It's 1. You have written here. And then another what you need to find out, D of 2 comma 1, because path is through 1, and another thing is 1 to 4. So these two things I have written and added it. So D of 2 comma 1 is nothing, it's an infinity, plus D of simply 1 to 4 is nothing, 1 to 4 also is infinity. Which one is minimum? We will take that weight as a answer. So minimum is 1. So we have updated now from infinity. Earlier path was D of 2 comma 4 was 1. So still its path is remains same. Minimum we are getting. Similarly for D2 comma 5, you can see earlier D2 comma 5 is showing 7. Still after updation also it is showing the same answer, same way. Here from also you can check it from D3 comma 2. So whatever other things you are getting, you have calculated in the same way, and you filled it this matrix based on this formula. So try to understand three important points in order to generate D1. The values in D1 will be taken from D0 matrix. Its first matrix, D1 is my first matrix, so its first row and first column will be same as D0 matrix. Its diagonal element will be 0, and rest all the indices, row and column indices, will be calculated based on this through the path 1. So everywhere, let's say you are calculating 3 comma 4. So 3 comma 4 of 0 matrix you will take, and what you will take here, sum of two values which is written in the D0 matrix in a form of 3 to 1 plus 1 to 4. So this way you have updated like this. So this way you got your D1 matrix. Fine. So this is all about written in explanation also, and for other things you can update in a same way. So this is all about what you got the answer of your D1 matrix, and D1 matrix is calculated like this. Now from this D1 matrix you will calculate another matrix, and that is known as your D2 matrix. So how you will calculate D2 matrix? Same way. We will go into our D1 matrix. Fine. We will go into our D1 matrix and we will take its second row and second column, because we are calculating D2 matrix, so we need to fix its second row and second column. And what will be its value? Its value will be same as you can see from your D1 matrix. So D1 matrix second row is infinity 0 infinity 1 7. So we have written like this, and second column was 3 0 4 5 infinity. So we have written like this. Fine. So we got the value of second row and second column same as from D1 matrix for D2. Fine. So this is the first step. So that is the second column and second row same as matrix from D1, because you are calculating k is equal to 2. So we will take from value from k minus 1 matrix. Okay. So D1 is our k minus 1 matrix right now. And second point is diagonal element will remain same. And same way we will calculate the other value. So let's, for examples, I have written like, let's say we want to calculate 3 comma 4. So 3 comma 4 we are calculating, let's say, this value. How we got this value 5? We will go to the old matrix of D1. So we will go to the old matrix of D1 and we will move to the 3 comma 4 value. So 3 comma 4 earlier was in one matrix, it was infinity. So we have written infinity. And second thing we need to find out 3 to 2 and 2 to 4. You can get from here 3 to 2 and 2 to 4 and add it 3 to 2 and 2 to 4. So 3 to 2 and 2 to 4 is what? 3 to 2 value is written as 4, and 4 to 2 value is written, and 4 2 to 4 3 to 2 is written as 4, and D of 2 to 4 2 to 4 is written as 1. So 4 plus 1. Now you can see earlier the value was in this particular 3 comma 4, it was in D1 matrix, it was infinity. 3 comma 4 was infinity, while we got a minimum value here. So through the vertex 2 as a middle vertex, we are getting one path which is better than infinity. So we updated it like 5 here. So I think you got the answer here, 5. Similarly, let's see, for example, 5 comma 3 you can check for 5 comma 3. So we'll check in D1 matrix 5 comma 3 value. So in D1 matrix, if you go 5 comma 3 was infinity, so we have written infinity. Another value from D1 matrix we need to take 5 to 2 and 2 to 3. So 5 to 2 was infinity and 2 to 3 was infinity. So nothing, no changes are there, so you got the same answer, infinity here. So 5 comma 3 is still infinity. You can check for one more value, let's say D of 4 comma 3. So D of 4 comma 3 in earlier matrix 4 comma 3, it was minus 5. Okay, so same way we have done 4 to 2 and 2 to 3, and we added it and we got the value minus 5 as a minimum. So in this way you got the table for D2. Similarly for D3, let's say you are designing D3, how many tables you need to design matrix? As there are 5 vertex, so you need to go till D power 5. So D power 3 is same as D power 2. Which columns will be same as D2 power 2? The third rows and third column from our D2 matrix. You can see third row and third column is same here as that in our previous matrix. So third row and third column is same as in D2. So D3 matrix you got third row and third column as same as your D2 matrix, and diagonal elements are 0, and same way you apply the rule now for this. So if you go for D 4 comma 2 value, you want to find out this value, then you will find out the minimum out of second matrix. Because we are calculating third matrix, we will go to the second matrix. What was the value earlier for 4 comma 2? We can check from here. 4 comma 2, it was 5. And what is the new value we can get if we are going through 3? So 4 comma 3 plus 3 comma 2, where in the new value. So 4 comma 3 plus 3 comma 2, you got minus 5, and 4 you added it, you got a better path here. So you can see earlier value was 5 in 4 comma 2, but you have updated it into minus 1. So earlier it was 5 in D2, but in D3 you see you updated it like minus 1. So this is the answer. Same way you can update other values in D3. Similarly for D4, you will go to D3 matrix and you will select 4th row and 4th column from D3 matrix and put same in D4 matrix, because we are calculating D4. So 4th row and 4th column from earlier matrix we will take as a same, and diagonal elements will be same, and same way we calculate the value as we have done in other matrices. Fine. So D4 we got like this, and at last we will go to our final matrix, and our final matrix is nothing, it's a D5 matrix. So for this D5 matrix, your 5th row and 5th column will be same as D4 matrix. Diagonal elements will remain same, and rest all elements you can calculate in the same way as mentioned here. So let's say take an example. Let's say we are trying to find out the value of all other values are same more or less, but let's say take an example of, let's say D13. We are trying to find out for new matrix through 5. So we will go to our old matrix, we will check the value of D13 in D4 matrix, it was minus 1. And let's say a path through 1 to 5 and 5 to 3 in the old matrix was minus 4 and plus 1. So what is the better path we are getting? Rather than minus 1, now you are getting minus 3. So minus 3 is less than minus 1. So we updated it like minus 3 here. Similarly for other value you can check D12 through 5. So we will go for D12 path matrix in D4 matrix, and D1 to 5 and 5 to 2 we will add. So we got a better path here. Earlier it was 3, but now we are getting 1. So we updated it like 1 here. Similarly D1 power 4 also we got a better path. Earlier it was 4, but through 4 if you are going 1 to 5 and 5 to 4, through 5 if we are going, then we got a better path, that the answer is 2. So we updated our matrix like this. So how you can conclude everything here? So basically you need to take 2 steps. First step, in order to generate rows and column in a particular D matrix, you need to take its corresponding before matrix generated value same. So let's say we are calculating D3, so we will take third row and third column from D2 matrix same. Diagonal elements will be 0, and then we can calculate it's whether we are getting a better cost through 3 or not based on this formula as I have told you. So if you assume you see your graph, final matrix you can see here, and your question was like this. So final matrix, let's say take an example of final matrix. It is showing what? It is showing reaching from 4 to 3. How much part it tells you? It tells you a cost of -5. Let's check from graph 4 to 3. You can check from graph 4 to 3. It is still -5. Means the direct path is the best path. Let's take another example. 1 to 3. 1 to 3. In our answer it was showing -3. So let's check through which path we are getting -3, because if you go to the main questions, 1 to 3 direct path is 8, but if you go through, let's say 1 to 5 and then 5 to 4 and then 4 to 3, so how much cost is going? -4 plus 6, that is 2, and 2 minus 5 is -3. So this is the path, and that is the shortest path, 1 to 5 and 5 to 4 and then 4 to 3. So all pair shortest path gives you the best answer here. In order to reach 1 to 3, what is the best cost you are getting? That is -3. So this is the answer written here. Similarly, for other things you can interpret. In order to reach from, let's say, 3 to 4, and answer is written as 5. So you can see directly there is no path between 3 to 4, but indirectly if you move, you can reach in a cost of how much cost? It is showing a cost of 5. Fine. So that you can check from here. So 3 to 4 you can want to check. 4 plus 3 7. 4 plus 3 7. 7 minus 4 plus this is 4 and this is 1, because this path and then this path. So 4 plus 1 5. 5 minus 3, that is not a path. So this way you can understand basically how much value a particular vertex takes to reach to another vertex through the mid vertex. Okay, so that is the meaning of all pair shortest path, and this is our final answer. So Floyd Warshall algorithm is basically not a greedy approach. It basically a dynamic programming approach. So what kind of approach it is using in terms of programming? Dynamic programming. And in dynamic programming you take decision sequence wise sequence. So you calculated D0, then D1, D2, D3, D4 and D5, and finally reach to your answer which is optimal in nature. So that's all for all pair shortest paths. Thank you.